are from AS120. We would like to present about the magnetic levitation, and our subject is Physics 150. I would like to introduce our team, which consists of 3 people: me, Muhammad Shafiq, Aiman, and of course Nafal. So for the firstly is the introduction of the magnetic levitation. Okay, so what is a magnetic levitation? Magnetic levitation, commonly known as a maglev, is a fascinating technology that resists the conventional constraint of physical contact. By utilizing the power of magnetic fields, maglev system enable objects to float, move, and even travel at high speeds without touching any surfaces. This innovative approach has diverse applications, ranging from the create a stable platform for precise laboratory work for revolutionizing transportation with high-speed maglev trains. In this role, 2 primary maglev suspension systems design electromagnetic suspensions (EMS) and electrodynamic suspensions (EDS) play crucial roles. This introduction explores the basic principle and application of magnetic levitation, shedding light on the captivating possibilities that arise when science and magnetism merge. Its significance: firstly, efficient and high-speed transportation. Future advancement in maglev could lead to even faster and more energy-efficient transportation system. This has the potential to transform long-distance travel and significantly reduce commute times. Environmental sustainability. Maglev's ability to operate without direct contact and friction can contribute to environmentally friendly transportation solution. As the technology evolves, it may become a key player in the sustainable and low-emission transportation. Thirdly, the infrastructure development. As maglev technology matures, it could become an integral part of future transportation infrastructure. This integration may involve the development of dedicated maglev corridors and intermodal transportation hubs. And lastly, technological integration. Ongoing innovation in maglev could lead to its seamless integration with other emerging technologies, enhancing overall efficiency and reliability. This integration may include advancement in the automation, artificial intelligence, and smart infrastructure.
Next, the relationship between electricity and magnetism. Electricity and magnetism are 2 related phenomena produced by the electromagnetic force. Together, they form electromagnetism. The relationship between electricity and magnetism is described by a set of fundamental principles known as electromagnetism. This branch of physics explores the interaction between electric charges and magnetic fields. How are they related? The proof of relation comes from the force of attraction of charges. Like electric charges repel, and unlike electric charges attract. The force of attraction or repulsion is inversely proportional to the square of the distance between them. The second proof of relation is force of attraction between poles. Magnetic poles always exist as a north-south pairs. Like poles repel and attract unlike. The final proof of relation is through the direction of magnetic field. An electric current in a wire generates a magnetic field around the wire. The direction of the magnetic field, clockwise or counterclockwise, depends on the direction of the current. This rule is also known as the right-hand rule in trains, also known as EMS or electromagnetic suspension. This concept, some people also call it the maglev concept. The train uses superconducting electromagnets. This kind of electromagnet can conduct electricity even after the power supply has been shut off. Furthermore, the system saves energy. Electromagnetic suspension system uses the repelling forces between magnet to counteract the gravitational force, allowing the object to float or be suspended in the air. And superconductor. What is a superconductor? A superconductor is a material that exhibits zero electrical resistance and the expulsion of magnetic fields when cooled below a certain critical temperature. The application of superconductors include high field magnets for scientific research. For example, in particle accelerators, maglev transportation system, power transmission cables, and sensitive devices for detecting magnetic fields. One bad side to it, which is the need for cryogenic temperatures.
Equation Lenz law, named after the physicist Emil Lenz, was formulated in 1834. It states that the direction of the current induced in a conductor by a changing magnetic field is such that the magnetic field created by the induced current opposes the initial changing magnetic field. When a current is induced by a magnetic field, then the magnetic field produced by the induced current will create its magnetic field. Thus, this magnetic field will be pushed by the magnetic field that created it. Lenz's law is based on Faraday's law of induction, which says a changing magnetic field will induce a current in a conductor, whereas Lenz's law tells us the direction of the induced current, which opposes the initial changing magnetic field which produces it. Hence, this is signified in the formula for Faraday's law by the negative sign. Potential benefits and challenges from magnetic levitation in public transport. So for the potential benefits, firstly, high speeds. Maglev trains can achieve very high speeds, often surpassing those of traditional trains. This can significantly reduce travel time between distant locations. Second, efficiency. Maglev system can be more energy efficient than traditional train system since there is no friction between the train and the tracks. This can lead to lower energy consumption per passenger. So for the third, environmental benefits. Maglev systems can be more environmentally friendly, especially if the energy used for propulsion comes from renewable source. Reduce energy consumption and lower emission contribute to a cleaner transportation system. So for the challenges, first, high initial cost. The construction of maglev infrastructure is expensive and the initial investment required can be a significant barrier to implementation. Second, limited infrastructure. Maglev system requires dedicated infrastructure and their deployment is currently limited. Expanding this system to cover extensive networks can be challenging and costly. So lastly, energy consumption. While maglev systems can be energy efficient, the construction and maintenance of the required infrastructure as well as the energy required for propulsion may still have environment impacts.
Future developments and innovation. Firstly, high-speed transportation. Continued research and development in maglev technology could lead to even faster and more efficient transportation systems. Maglev trains, for instance, might reach higher speeds, reducing travel times between cities and revolutionizing long-distance commuting. Secondly, energy efficiency. Innovations in the energy efficiency of maglev system may focus on reducing power consumption and improving overall sustainability. This could involve advancements in magnetic technologies, control system and energy storage. Thirdly, infrastructure development. Future innovations may focus on the integration of maglev infrastructure into existing transportation networks, potentially allowing for smoother transition between maglev and traditional transportation modes. And lastly, emerging application in industry. Maglev technology could find new application in industrial settings, facilitating the precise movement and the positioning of materials in the manufacturing processes. This could lead to more efficient and automated production lines.
Conclusion, magnetic levitation represents a cutting-edge technology that harnesses the principles of electromagnetism to suspend objects in mid-air without any physical contact. This innovative method offers numerous advantages such as reduced friction, minimum wear and tear, and improved energy efficiency, making it a promising solution for various applications, including transportation systems like maglev trains, while challenges such as cost and infrastructure development remain. The potential for magnetic levitation for revolutionize industries and redefine conventional modes of transportation is undeniable, pointing toward a future where this technology plays a crucial role in shaping efficient and sustainable systems.